All right, let's talk about something that's at the core of writing good, solid Java code, typecasting. We're going to break down what it is, how it works, and why it matters so much. Let's get into it.
But first, before we even look at a line of code, let me ask you a simple question. How do you fit a gallon of water into a pint glass? The answer is, well, you can't, right? Not without making a huge mess. Just keep that picture in your mind. Because, and you might not believe it, this is a problem that Java programmers deal with all the time. They're constantly trying to fit one kind of data into a variable, a container, that was built for another kind.
And that brings us to the heart of the issue. See, Java is very strict about its container system. You can think of it like a kitchen, where every single ingredient has its own perfectly sized, specially shaped container.
In Java, every little piece of information has something called a data type, and you shouldn't think of it as just a label. No, it's literally like a container built for one specific purpose. An int container, it only holds whole numbers. A double container, it holds those decimal numbers. Each one is specialized.
And here's the golden rule. Java will not let you pour the contents from a big, spacious container, like a double that can hold all those decimal places, into a smaller, less precise container, like an int. Not unless you give it a very specific command. It's really a safety feature, you know? It's there to prevent you from spilling data all over the place.
So, what's that special command? How do we tell Java, hey, I get it, but I know what I'm doing, please pour it anyway? Well, that's where typecasting comes into the picture.
Typecasting is just the official programming term for this whole conversion process. It's how you, the programmer, tell the computer to change a value's data type. You're literally telling it to pour the data from one of our containers into another one.
But here's the thing. Just like in real life, there are different ways to pour something. There's the easy, clean way, and then there's the way that requires a little more care and attention.
Let's start with the easy one. Programmers call this widening casting, and you can just think of this as the safe pour. No mess, no stress. See, widening casting is totally safe because it's just like this. You're taking a value from a small container, like our whole number int, and you're pouring it into a much bigger, roomier container, like a double. Is it going to fit? Of course, it's a perfect fit. Nothing gets spilled, no data gets lost.
In fact, this is so safe and so obvious that Java doesn't even make you think about it. It just does it for you automatically. You can write code like this, assigning an integer to a double, and Java just handles the conversion behind the scenes. No special commands needed. It just works.
Okay, now for the other side of the coin, narrowing casting. This is our gallon into a pint glass situation. This is the careful, deliberate, and sometimes risky pour.
So here we're doing the complete opposite. We're taking a large, precise value, like a double, and we are trying to force it to cram it into a smaller, less precise int container. And what happens? Spillage. Something has to give, and in this case, that something is your data. You are going to lose information. Because of this risk, Java makes you do it on purpose. It forces you to be explicit. See that little int in the code? That is you, the programmer, raising your hand and telling Java, yes, I know what I'm doing. I know I'm probably going to lose some data here, and I accept the consequences. Go ahead and make it happen. So what happens when you run that code? The variable myInt now holds the number 9. The .78, well, it's gone, vanished. It's been truncated, spilled all over the digital floor.
So if you remember one thing, let it be this. It's all summarized right here. Widening, small to large, always safe, always automatic. Narrowing, large to small, always risky, and you must do it manually. Seriously, this slide is the perfect cheat sheet.
So far, we've talked about losing a bit of decimal data, which might not seem like the end of the world. But what happens when you make a really bad pour, especially when you're dealing with more complex things called objects?
Well, you get this. This ugly error message is what stops your entire program dead in its tracks. It's the digital version of dropping that gallon jug and watching it shatter into a million pieces.
A class cast exception is what happens when you try to force an object into a completely incompatible type. It's not just that the container is the wrong size, it's the wrong shape entirely. This is Java's emergency brake. It's the system screaming, whoa, stop, that will never fit and you're going to break everything if you try.
So let's just quickly recap the absolute essentials. Number 1, always think of Java's data types as containers. Number 2, widening is the easy automatic pour from a small container into a big one. Number 3, narrowing is the risky manual pour from a big container into a small one, where you will lose data. You have to tell Java you want to do it. And finally, that class cast exception. That is a catastrophic failure that you need to code carefully to avoid at all costs.
And that really leaves us with a final thought here. Typecasting is an incredibly powerful tool. It gives you, the developer, direct control over how your program handles data. But with that control comes responsibility. The key to becoming a really great programmer isn't just about knowing how to do this, but developing the wisdom to know when that control actually gives you power and when it's just adding risk you don't need to take.